Okay, well, it's fancy to see you here. We got to I crawled out of the black hole. I'm back on this side of the event horizon. So you want to start with some of the questions?
Well, is there anything else? Yeah? Okay, great. Go for it.
If you'd like to, Sim, yeah.
Yeah.
Okay, we're going to go with question number 1. This is from Lalana Rose. She says, I presume she, hi, I've just joined the Academy a few days ago. Lifelong membership, yay! Awesome, Lalana. Question, I have heard you say the Earth is expanding and that it's 60% larger than it used to be. Do you theorize it will just keep expanding, perhaps getting to be the size of or surpassing, oops, it just jumped, right, or surpassing our larger outer planets? Do you think they eventually kind of burst, not being able to support itself any longer? Wondering if interstellar investigations have records from other solar systems of the largest observable known planet sizes. So my question is, do you think there are specific evolutionary trajectories for planets themselves who are their own complete living beings and systems? Although my question is non-holographic thinking, meaning what we think of as a huge planets from our perception are perhaps just itty-bitty electrons spinning around some nucleus of a more vast fractal piece of the hologram. It's making my head spin.
Well, let's welcome Lana on there first. Let's see. Hi, welcome. We love seeing our new delegate.
Thank you.
Thank you so much for joining us. Yeah, great. All right.
That is a very good question. Yeah, some good observations. A pretty good narrative, and get used to your head spinning because everything else says. So you don't really have a choice in the matter, and I mean that literally, pun included. The matter that you're made of is spinning, but the idea that you can fractalize planets is correct. You can think of it as galaxies and universes, if you'd like, or even larger, orbiting multiverses, or subatomic particle at the subatomic level. Certainly you can think of them as orbiting singularity. That's the most important part, and that is that it's orbiting a black hole or a singularity at the center. And that is the controversial part of the equation, is that it predicts that angular momentum, or at least orbital systems, always centered by singularity at all the scales. So that means that the sun is a black hole, which means that the Earth is a black hole, which means that the center of all your atoms are black holes, and that there's black holes all the way down through the spin of creation. So your head will start spinning as you contemplate it. But let's talk about some of the scales. So you're asking about the planets and the solar system. The planets. So just to recapitulate a little bit, planetary systems, at least the Earth, has a theory of plate tectonic, in which plates are moving away from each other, which demands a certain amount of distortion to actually make the theory agree with reality. That is, if you take the continents and you try to stick them together, you get a lot of distortion you got to do a lot of tweaking for it to come together nicely, because the Earth is not flat. It really isn't, like for all these flat Earth people out there. And so it's not. And so you can't actually make the continent, like flatten them and then try to put them together. You can keep them spherical and try to put them together. You still need a lot of distortion. And this distortion is not really necessary. It's much cleaner if you actually assume that the Earth was smaller, 60% smaller, and that all the continents, when they were together, were made up the crust of the Earth, and then as the Earth grew, the continent moved away from each other. And it makes much more sense in a rotating object that the masses would be distributed, fairly equally as the object grew, if it did. So the idea that the masses would all go to one side is not really possible. So it's much more accurate to think of it as centrifugal forces, for instance, moving masses away from the center. Now, this theory was first elaborated on in the 70s. I didn't know that personally. I came up with the same idea that the Earth must be growing when I was working for 5 years in my van and figuring out the physics of the universe. And and then I realized that somebody else had figured the same thing out. Very good scientist, planetary scientist, that described the Earth as growing and realized that it was a better match for plate tectonic. And then if people are interested, they can go to YouTube and type in expanding Earth theory, and they'll see that there's been nice animations that were done to show the movement of and then it was done for the moon as well, as you mentioned in your statement. It was done as well for some of the moons of Jupiter, I believe, and so on. And it's a really good match. Now, the expanding Earth theorists, some of the physicists involved, planetary scientists, have approached me a few years ago and asked me why the planets were growing. And I told them I could give them the answer, but that they wouldn't like it. That was the case. I told them that it was because there's a black hole at the center of the Earth and it's producing matter. And as it produces matter, it creates pressure and it expands the surface. And you know that this is the result of the exchange of information at the quantum level at the surface of the black hole, singularity at on the surface of the Earth. That matter creation is not just occurring in the Big Bang, but it's occurring at the center of orbiting system, like the center of galaxies, where we see jets of matter emerging from the poles. And so they were interested, but it was a little too scary to publish. So far it's not been known. So now, are planets going to continue to grow? Yes, probably they would continue to grow, but then they would as well reach levels where they would, have to have rearrangements, of the orbitals, because they would increase in mass, right? And go through cycles in which a planetary system probably eventually would kind of catapult itself out of the solar system. So you could have rogue planets flying around with very long orbitals. You could even think of planets that would have orbitals very wide, crazy orbitals between two black hole stars, right? Because the theory actually says that the sun is a black hole as well. And, Of course, if you say that to a standard physicist, you will say, no, it's not possible, because if you solve Einstein's equation for the black hole mass of the sun, of our sun, you should have only an 18-kilometer radius. But it's not, that's only assuming that the sun is homogeneous. You can have the core of the sun collapse into a black hole, or the core of the earth collapse into a black hole, and then the rest of the mass orbiting that black hole, and the addition of the mass of the core, or the singularity in the middle, and the mass of the material that's orbiting that singularity adds up to the mass of the object, like the mass of the sun. And that's actually why the sun is ringing like it does. The sun rings like a bell. And so is the moon and the earth and all the planets in our solar system. And they all have very specific tonalities, and that's consistent with a hollow structure inside the sphere, which is the space in which the matter has collapsed into the singularity in the middle. And so, it leaves a space. So you have a singularity, like a little sun in the middle. You have space, and then you have the crust, the magma in the case of the sun, in the case of the earth, with the crust over top of it and all this. And that's orbiting that singularity. Or in case of the sun, you have all the plasma, which is called the orgosphere of a black hole. And in the case of a galaxy, you have all the bulge around the black hole in the middle. It's a huge bulge. It's almost 20% of the galaxy. And that has a maximum amount of star density inside the galaxy there. Many of these stars being black holes. And that, in fact, they're finding a lot of black holes around the center of galaxies, thinking that somehow they were stars. Listen to this. Remarkable. They're saying they were stars that went out into the galactic disk and then collapsed into black holes and got reabsorbed towards the center. And that's why there's such a density of black hole in the middle. There's a problem with that explanation. It's very obvious to just simple physics, like very, well-established physics. That is, a star that would collapse into a black hole would have the mass of the star, or even less than the mass of the star, because it lost material, as a black hole. It's not because it became a black hole that it has a larger mass. It has the same mass. It's just much more dense, much more compressed. So why would they get sucked back in towards the center? Since their mass doesn't vary, they should continue to orbit exactly where they were. And it is much more logical to realize, which, I've been championing for 30 years, that, galactic centers make black holes that eventually become stars because they produce enough material, because the black holes produce matter, puts enough material in its surrounding to eventually have enough plasma that it lights up like a star. And when the star explodes, because it has reached its maximum expansion possibility, that's called a carbon cycle, which we have well documented in the standard model. That is, the carbon starts to make a harder shell, and the pressure from the inside continuing to produce matter explodes that shell. And then what do we see when we see the star has exploded? We see a black hole, right? You see, the question you ask is a deep question about the source of reality. So I can't just answer it very easily and, very quickly anyway. But because it went from your head spinning to the source of, matter. So, you know, this is a completely different cosmology that emerged. And it's true that moons and stars would evolve as the Earth, moon and stars and planets would evolve as the Earth did evolve, and the planetary system, including Jupiter and Neptune and Saturn and all this, would like change orbits as the energy levels change in the solar system. Did you have comments on this?
Did I what?
Have comments on this?
Yeah, and maybe we could take it a little smaller, like, so that maybe just the Earth.
Yeah.
You just continuing to expand, and is there, you know, can we wonder, is there a limit? Will it eventually kind of be like, no, I can't do it anymore, I can't do it more, or like it'll burst, or what?
Well, just like a star, it should definitely go through some transformation. But the singularity that's in the middle is never going to go away. So, you know, it will keep producing matter and it will change orbitals. Let's just say that the changes that it will go through are not conducive to society living on the surface. And that's why any civilization in the universe has to eventually learn to fly, because if they don't know how to live in space, or they don't have the technology to do it, they're probably not going to survive, because planetary system eventually go through transformation, whether it's from its own internal mechanics or you know, meteorite hits or a sun flare, you know, and they lose the atmosphere. I mean, a society really has a limited amount of time to learn to control gravitational fields and get off the surface of their planets. There's as well only a limited amount of resources on the planet. If you're gonna be a civilization that expands and continue to grow, you have to continue to grow. And just like the rest of the universe, the planets, the stars, the galaxy and everything, and the universe itself, which is expanding, and you have to be able to eventually expand your horizon and be able to live in space, travel through space, live in your solar system instead of just your surface of your planet, live in your galaxy, maybe live in your local cluster of galaxy, and then eventually live into the supercluster and maybe the universes, you know, and the sky is no longer the limit.
Yeah,
good one.
I'm much more grateful. I mean, it might be 1 million years or 10 million years, but the actual heaven on earth that we have, the precious gem over here, is pretty amazing.
Yeah. Thank you so much.
Thank you, Lalana. Great that you joined us. Thank you so much.
Yeah,
okay.
Welcome to the Academy. We're excited to have you. Blessings. All right, Marshall. That was
Next.